All right, we're moving on to lesson 6-7. You can see the title is Common Logs. We mentioned briefly the other day that there is a special logarithm that we don't need to write the base for, and if there is no base showing, it's always understood to be 10, and logs like that are called common logarithms. It's all about the fact that we have a base 10 number system. And so my little blank here is just a little reminder, common logarithms are base 10. And these are going to be the focus of today's lesson. I thought it would be helpful to take just a moment. I always like to see where we've come from and then how does that compare to where we're going. We're leaving something like this. Now this is a really simple example. Don't you wish you had some of those on your homework last night? But when we're solving log equations like this, I've been trying to get across that to solve a log equation, you need to convert it into exponential form first. Now that's pretty easy. We can see that the exponent required in this case has got to be 3. But I just want to make sure you understand that to solve a log equation, we changed log equations to exponential form. Well, today, where we are now is we're going to be solving exponential equations. We're trying to find out what the value of this variable is, which happens to be the exponent. So you probably guessed it, to solve exponential equations, we're going to have to change them to log form. The reverse of what we did yesterday. Something else that is happening that we really haven't had to deal with yet, previously this may have been something like this, 3 to the x power equals 9, and the exponent was pretty easy to determine. We can just tell it's a whole number 2. Well, that's obviously not the case here, so I'm going to have to give you a formula and your calculator to help you with these types of exponents that are not just whole numbers or easy to determine just by looking. And that's going to be the focus of today's lesson. First of all, these two little quick exercises are just to make sure you understand where the log button is on your calculator and how to use it. Because for common logs, as far as your calculator is concerned, when you hit the log button, it automatically thinks base 10. That's all it knows. So just quick little practice. Find the log button. It spells L-O-G. I think everybody has the same calculator. So when you hit the log button, if I remember correctly, you'll see the word log and the left parenthesis will appear. So all you need to do is put in the 3 and close the parentheses. And all of your answers today are going to be rounded to the 10,000th, which is 4 decimal places. So let's see, I don't remember what that is. I'm going to have to call on somebody. Do I have any volunteers? What is that? Yes? 0.4771, just show of hands, just to confirm everybody got that. Okay. I don't think we need to do letter B, but I just want to make sure you understand where the log button is and how to use it. It's pretty simple because you're going to use it quite a bit in this lesson. So for sake of time, let's just jump into actual homework type problems. So this is the kind of thing you're going to do on these problems, solving exponential equations. Well, I mentioned earlier that for exponential equations, we need to convert them or change them into log form. And I want you to do that as part of showing your work. Just a really quick, simple step, but hopefully it's going to be helpful in training you that exponential needs to be changed to log and vice versa. So in log form, log equation form, it would look like this. Log base 6 of 40 equals our required exponent, the exponent that we're trying to solve for, which in this case is called x. Okay, so here is where we're going to need to call on a brand new formula. And this formula is called the change of base formula. Very easy to use. It's just going to be your job to know when to use it in cases like this. And with practice, that'll get much easier. So here is the change of base formula in action. We're going to go back to your calculator, and we're going to need that log button. So if you want to go ahead and press log, and it shows the left parentheses, here's the change of base formula. We put log and then the top number. Here I'm calling the top number that's above the base, which is 40. Okay. Then you hit divide by, hit the log button again, so you're going to hit log twice, and then put in the bottom number. So it's easy to remember. In this fraction, the top number stays on top, the base goes to the bottom, and our answer needs to be in, you can go ahead and hit enter if you haven't already, and our answer needs to be a decimal rounded to 4 decimal places. So can somebody give me what that is? We'll say x is approximately, since we're rounding. Somebody have that? Yeah? All right, and that would be, everybody get that? That would be our answer for this problem. So real fast, I want you to be intentional. Take the given problem, write it as a log equation, and then you just jump into this change of base formula. All right? Let's try this one. This is called an exponential equation because we're trying to solve for the exponent, letter A. So we need to convert it to a log equation to make that happen. So here it is as a log equation. Log base 2.1 of 8.25 equals the exponent A plus 2. Remember, logarithms should always equal the exponent. All right, so once again, we're going to pull out the change of base formula. So in your calculator, you can hit the log button, put in 8.25, that'll be the numerator, divided by, hit the log button again, put in 2.1. In first period, some people were not getting this right because they forgot to close the parentheses. So just make sure that you close the parentheses for this numerator part. So somebody give me that decimal, and it's okay to go ahead and round it to 4 decimal places. Who's got that? Yeah, go ahead. 2.8442. Now this one's a little different because I've got one more step involved to solve for A. Okay, I didn't have that in the previous problem, so now I need to subtract 2. So you probably still have that decimal in your calculator, so you can just do minus 2. And the rounded version should be 0.8442. All right, any questions so far? Change of base formula, when we need it. We need it when we're solving exponential equations. But make sure you change the log form first. All right, there's one oddball problem. Seems like there's always one that's different from the rest. So I'm going to help you out. And when you get to your homework, your number 26 is a lot like this. And it's different from all the others. So what I do with this problem, you'll do the same thing for number 26. Okay, so first of all, I am going to change it to log form like we did the others. Log base 11 of 5 to the b power is equal to the exponent for the base of 11, which is b minus 3. Okay, what makes this different than the others is this exponent here, but I've got a property that we learned yesterday that helps me deal with this. What is that property that says that this exponent b could be used as a factor or a multiplier? Remember that property? Power. Power property. All right, very good. So according to the power property, I can legitimately rewrite this as b times log base 11 of 5. And that's going to be necessary. That's going to be a necessary move in order to solve these types of problems like we've solved the rest. So, all right, so now let's jump to your calculator and give me, using the change of base formula, do log 5 divided by log 11. Log 5 divided by log 11. And when you get that, somebody read that off to me. I think we'll just give me the whole decimal. Anybody got it? Okay, go ahead, Kate. 0.67118. Okay, everybody good? Now, I put b here, I brought it down, used it as a factor, so I'm just going to let b show here as being multiplied times that. All right, so I'm going to solve for b. You got a couple of options here. I'm just going to choose to leave that decimal in your calculator, okay? And I'm going to subtract 1b from both sides. So all you need, I don't need to say 1b, but you get the idea. All you really need to do in your calculator with this sitting there is just do minus 1. I essentially subtracted b from both sides. So what is this decimal minus 1? And when you get that, somebody read it off to me. Some negative decimal. Got it? And that's b equals negative 3. You with me so far? Okay, so how do you think we're going to solve for b now? We're going to divide. So we're going to do negative 3, and I ran this decimal out because that's a more precise way. That's quite, closer to the actual answer. So in your calculator, you're just going to do negative 3 divided by this decimal. Negative 3 divided by negative 0.328812259. And let's see, Heather, read that off to us, and you can round it now. Okay, who got it? All right, so I just want to make sure you got one like this. The rest of them are more like the previous ones that I did, but I just want to give you a little bit of a heads up. And you're going to have to use the power property in this case. And again, that'll be number 26. Yeah? No, it's negative divided by negative. Yeah. All right, any questions? Everybody good? All right. Let's try one more. So once again, this is an exponential equation. We're going to turn it into a log equation. Log base 7 of 20.42 is equal to the exponent x squared. All right, once again, get a lot of practice with the change of base formula. So in your calculator, you're going to do log 20.42 divided by log 7. And somebody give me that decimal. Okay. 0.2. Okay, now we've got to solve for x. We've been here before. To solve for x, we're going to need to do the square root of both sides. So what I would do to make it easier, you've already got this long decimal in your calculator, I would just hit this button and then raise it to parentheses 1/2. That's another way of doing the square root. Now you got to be careful here because we've talked about this in the past and it's back again. When you're solving, this is essentially a quadratic equation, we should get two answers. We got to remember plus, minus. I'll put approximately. So the square root of this number plus minus, who's got that? What you got there? Okay, who got it? Okay, good. So not everybody did. Anybody have a question? Everybody see what we did there? We're all good? All right. Let's take a look at some inequalities. Similar, but a pretty big difference. So pay close attention to what I'm about to do because it's easy to forget. All right, I'm going to change this into log form just like we did with the equations, but I want you to pay close attention to the variable n, and you can think of it this way. The variable n and then the inequality is pointing at 33. Do you see that? It's like n is greater than 33 in a way. When I change this into log form, I have to maintain this positioning with the inequality. N still should be greater than 33 when I convert it to log form. Okay, let me show you what I mean. It's going to be log base 5, 33, and then normally I would say equals 4n. Well, here 4n is greater than 33, so when I rewrite the log form, I need to make sure it still says 4n is greater than 33. All right, did you catch that? That's big because if you forget that, you're going to get the right decimal, but you're going to have the wrong inequality. All right, so now we just go through the normal process, change a base. So get your calculator, log 33 divided by log 5. Can you give me that number? Log 33 divided by log 5, what is that decimal? Okay, and now to get our answer, all we have to do is divide that decimal by 4. See, Whitney, tell me what you got for that. 0.5431. So this says 0.5431 is less than n, or if you prefer, you can turn that around and say n is greater than 0.5431. But this is the big takeaway. You need to make sure you remember that, make yourself a note. When you rewrite in log form, make sure your inequality matches what the original exponential inequality says. Okay, let's try one more. So I'm going to write this as the log form, log base 6, 4p. If you notice that it says basically p is less than or equal to 4p, just pay attention to the exponent in relation to the inequality, because when I rewrite this, I have to basically make sure it says the same thing. You could look at it as 4p is greater than equal to, and that's what it says here. Big, important step. Okay, change of base. Log 4 divided by log 6. And let's see, Colin, can you give us that decimal? Okay, and notice we're multiplying by p. And so we're trying to solve for p. So once again, you have options. I think it's easier since you already have this in your calculator. We're basically going to subtract p from both sides. So leave that decimal in your calculator and then just do -1. And let's see, Hannah, do you have that? -0.2263 greater than equal to p, don't forget the p, greater than equal to -1. All right, and now it should be pretty obvious how we're going to solve for p, but remember, we're about to divide by a negative number. Don't forget that rule. Dividing or multiplying by a negative causes us to reverse this inequality. Okay, so we're ready for our answer. We changed the inequality direction because we divided by negative. So what is that? -1 divided by that decimal. Can somebody give that to me? Colin? Seven, you said 4? Okay, I'm going to leave it like this. Who else got that? You didn't get that? Okay. Okay. Well, did you do -1 divided by this decimal? Try it again. Somebody else give me an answer. Yeah. 4.4189? Okay, good. Very good. Real fast, just hang with me for 1 minute, and I will do this on the video, but when you get to these problems, this is really just an exercise of the change of base formula again. So for letter A, you're going to do log 7 divided by log 3. And you're going to let the calculator crank out a decimal and you round it, and that's your answer. So you're just practicing the change of base formula once again. All right. Here it's log 13 divided by log 9. All right. The assignment I think I provided for you. Did I? Okay. Let me know if you have any questions.